Hi, this is Mr. Moss, and in this video we're looking at partial quotients as a strategy for multi-digit division. This is a guide for grown-ups, and what I mean by that is I'm going to walk you through a bit of how and why we do things the way we do them with partial quotients and some strategies that you can use as you're supporting your fourth grader with learning this new skill. So let's get started. Let's take a look at this problem here, 583 divided by 3. This is a problem that you might know how to solve using long division, and that's certainly a tried and true strategy. It's something that we still certainly teach kids. But I want to introduce you to the idea of partial quotients. And what that means is we're breaking down this division problem into smaller, easier to calculate parts, and we're able to get smaller quotients for it. So let's take a look. We have 583, and that's divided by 3. So far this looks like we're doing long division. Where this ends up looking a little bit different is we draw a line down the page, and I'll show you why. In long division, there's a set series of steps that you go through. 3 goes into 5, how many times, and we go all the way through. And there's a right way to do it. And if you put any numbers here that aren't the right ones, you're going to get the wrong answer. Partial quotients gives you a bit more flexibility. It gives students a bit more flexibility to break this number down as a way that makes sense. We ask, what's a part of 583 that I can pull out that is divisible by 3? For example, I can pull out here 300. Well, I know that 300 is divisible by 3. 300 divided by 3 equals 100. 3 goes into 300 100 times. And when I subtract what I've done so far, I have 3 minus 0 equals 3. 8 minus 0 equals 8. I have 283 left. So then I look at it and I say, okay, what else can I pull out? I can pull out another 300, but I know that 3 times 9 equals 27. So 3 times 9 equals going to equal 270 I can pull out. 3 goes into 270 90 times. So I'm going to subtract that. 3 minus 0 equals 3. 8 minus 7 equals 1. So now I have 13 left. So now the question is, what can I do with my 13? Well, let's see. What else can I pull out here? I can pull out 12. And I know that 3 goes into 12 4 times. And when I do my subtraction, 13 minus 12 equals 1. Now, can I pull out anything? Can I put 3 into 1? No, I can't. So that's showing me that that's going to be my remainder. So I'll put a little r here to show that that's my remainder. And I take these partial quotients, and that's really what I was doing. 300 divided by 3 equals 100. 270 divided by 3 equals 90. 12 divided by 3 equals 4. These are partial quotients, and if I put them all back together, I'm going to get my total quotient. 100 plus 90 plus 4 equals 194. So my quotient is 194, but with a remainder of 1. The reason why we like using partial quotients as a way to get started is there's no one right way to solve this. For example, if I try writing out the same problem, got to use my same color here. 3 into 583. So for this same problem here, I've set it up the same way. This time, I'm going to break it up in a different way. Maybe for me, I'm trying to think. 3 into, well, maybe I can do 450. That should work. 3 into 450 if I want to challenge myself. 3 goes into 450. I know 150 times. And now if I do some subtraction here, I'm left with 133. So that's now a smaller amount. So now I'm asking, okay, what else can I take out from here? Well, let's take out 90. There's no right way to do this as long as I'm taking out parts. 3 goes into 90 30 times. And when I subtract, I've got 3 I've got 43 left here. So I'm getting closer here. All right, so now I've got 43. I have to forget how many times that's going to go into it here. Let's try 43, and I'm going to pull out 30. Now, you might be thinking, oh, we could pull out 33. That's going to be a nice, easy one to work with, or 36, or 39. And you're right, I could do all those, but I'm going to break it down. I'm going to pull out 30 here. And so 43, okay, 3 goes into 30 10 times. And that's now leaving me with 13. Oh, I was there before, actually. I had 13 here. I had 13 before. So I actually added a couple steps to this version. And you know what? That's totally fine to do. 13, and now I'm going to pull out 12. 3 goes into 12 4 times. 13 minus 12 equals 1. And again, I can't do anything with that 1. I can't do 1 divided by 3 here. So that's my remainder. And now let me add up my partial quotients here. 150 to 1 plus 130 is 180, 190, 194. So I got the same answer here. I'm just getting it in a different way. But my same quotient, 194, with the remainder of 1. The idea is that students break up numbers differently. Some kids might be really confident. They might want to jump up to a large amount that they can take away at once. Whereas some kids may want to go with small, easy to manage chunks, like taking 300 out, because that's easier to work with. Some important points as you're supporting your fourth grader is to make sure that they're writing the numbers in the right spot. Sometimes kids write numbers off to the side. Like their 3 goes into 300, they might put 100 up here. Or 3 goes into 270, they might put the 90 over here. And they might have the numbers squished together and add them up in one spot here. So you really want to try and help kids to keep their rows organized so that it's making sense. Their dividend is going to be next to the partial quotient. Dividend next to the partial quotient, dividend next to the partial quotient. That's going to be help them to understand how and why they're doing what they're doing. And it may be helpful to them to use different colors just the way I'm using them right now. Let's take a look at another example here. 970 divided by 6. So let's set this up the same way. 900, oh, that's a terrible marker here. Let's get a fresh one here. 970 divided by 6. All right, so we're going to go through the same process. Immediately what jumps to my mind is because 900 is bigger than 600, let me just take out, to make my life a little easier here, let me just take out 600. So I'm going to remove 600. 6 goes into 600 100 times. That's always a nice way to just get a jump start here. 6 goes into 600 100 times. Let me do my subtraction. Oops. Subtraction sign goes right there. And I've got here 370 left. I can't take out another 600, but maybe I can take, let's take out 300. All right, so right here, I'm removing another 300. 6 goes into 300. Well, I know that 6 goes into 30 5 times, so 6 goes into 300 50 times. So if I do my subtraction here, 0, 7. Okay, now I'm down. I only have 70 left. Well, let's use my 10. All right, so let's pull out another 60 here. 6 goes into 60 10 times. 70 minus 60 equals 10. Now, again, I could have done 66 here, and then I would have gotten right to the answer. But you know what? I'm breaking it up into multiple steps, and that's fine. So I've got 70 minus 60 equals 10. 6 goes into 10 one time. I'm sorry, I'm going to pull out, I'm sorry about that. Let me go back. I'm going to pull out 6. 6 goes into 6 one time. And 10 minus 6 equals 4. Now, this is, again, where I have to look and say, okay, is there anything else I can pull out? Can I put 6 into 4? No, I can't. So that's telling me that my 4 here is going to be a remainder. And now I have to add it up. 100, 150, 160, 161. That tells me that my quotient is 161 with a remainder of 4. Sorry, you can't quite see that right there. 161 with a remainder of 4. Now let's do the same problem, but just show that we can use a different strategy for being able to solve this. All right, so let's do, again, 6 into 970. Make sure we have plenty of room here. So maybe this time, instead of breaking up, you know what? Everyone thinks about numbers a little bit differently. So I'm going to take out 300 for right now, because why not? Well, we actually did that before down here, so I know that 6 goes into 350 times. All right. And we have left 0, 7, 670 here. And maybe I'm looking at this thinking, ooh, 70 is close to 60. And I know that I can take out, I can divide 60 by 6. So maybe for right now, I'm just going to take out 60 in hopes of getting this to be something that's a little bit easier to work with. There's no wrong way to do this. 6 goes into 60 10 times. 670 minus 60 equals 610. And maybe now I'm going to look at this and say, gee, let me take out another, I don't know, honestly, I think most students would probably look at this and take out 300 again. Or I'm sorry, 600 right now. So let's take out, sure, let's jump ahead here and do 600. I think that's probably the most logical thing that most students would do. So 6 goes into 600 100 times, and we're left with 10. And isn't it interesting? We're kind of using the same numbers. Here's our 50, here's our 10, here's our hundreds, and now we're going to be left with taking out another round of 6. This is the part now where it's all going to max up. 10 minus 6, 6 goes into 6 one time, leaving a total of 4, just like we had before. So this one, we just changed the order a little bit. That's my remainder. And if we add up, 50 plus 10 equals 60, plus 100 equals 160, plus 1 equals 161. So in this example, with a remainder of 4. In this example here, really all we did is we changed the order, but you can see it made sense that for a student, they might look at this and say, okay, I can take out 300. That's a fact that I know well. 6 times 5 equals 30, so 6 times 50 equals 300. And then I'm at 670. Well, let me take away 60. That's going to make it easier for me to work with here. That's now bringing it down to 610. And I can take out 600 and divide that. It's just a different process. So your fourth grader could come up with any number of different strategies, and any of them are going to be fine. Let's do one last example. If you feel like you've got the gist of this here, you can feel free to move on to better things right now. This is just another example if you'd like it. Let's take a look at 384 divided by 8. So we've got 384 divided by 8. Now this time, I can't do my 100. In the previous example, I was able to take away 600 because that went in 100 times. In the first example, I could take out 300, which went in 100 times. This time I can't do it. I can't take out 800. So I have to look, and this is a little bit different now. Okay, so 8 into 384. Well, I know that 8 times 3 is 24. So 8 times 30 is going to be 240. Let's take that out. All right. So that's going to be 8 times 30. 8 goes into 240 30 times. Do our subtraction here. 4, 4, 1. Now I have 144. So now let's see. 8 into 144. Well, I can't do 8 times 8 times. I'm sorry, I lost my train of thought. Let's see. Let's do 8 times 5 is going to be 40. 8 times 50, that's going to be too big. 8 times 20, that's going to be 8 times 20 is 160. That's going to be too big. Let's just take out an 80 here. All right. 8 goes into 80 10 times. And again, we're going through our subtraction. Now I have 64. Boy, so now what can I do? This is where students have to use their math fact fluency here. What math facts do they know that they have right at their fingertips to be able to solve this particular problem? Maybe I know that 8 times 5 equals 40. And maybe that's the easiest step for me to do right now. So let me take out 40. That goes in 5 times. Now I'm left with 24. Now we know that they could have put that in evenly and we'd be in good shape here. But you know what? There's so many different ways to do this here. So we've got now 24 remaining. I can pull out all 24. 8 goes into 24 3 times. We're left with 0. So there's going to be no remainder. So for this problem here, 30, 40, 45, 48. It's going to go in evenly, no remainder. But once again, I can do this problem in any number of different ways. Let's try it in another way. 8 into 384. So we're going to start off here. Let's see, before I did a divide, I took out 240 because I know I could do 240 divided by 8. Let's do 320 this time. All right. So I know that 8 times 4 is 32. So 8 times 40 has to equal 320. So see, I'm using a different strategy this time. Subtraction, 4, 6. Now I'm down to 64. So I was able to really cut through a lot of steps involved here. And another student may know, hey, 8 times 8 equals 64. I can take away all 64 right now. That's going to go in 8 times. 64 minus 64 equals 0. And now I'm done a lot faster. And now I've got, add them up, 40 plus 8, 48. So as you can see, these are two different ways to get to the same quotient. And there was some overlap. That's the interesting part. Is here I had 30 and 10. Here I had 40. And I got there by taking out 240 and then taking out 80, which is, of course, the same as taking out 320. I had my 5 and my 3, which is the same as getting 8, because I broke up 64 into 40 and 24, which is the same as just using all 64 all at once. So they're really different ways of reaching the same outcome. This has been Mr. Moss, kind of walking you through some of the steps of partial quotients. This is why we go through partial quotients. Again, it builds that flexible thinking, and I hope this was a helpful guide for you. Have a great day.